Welcome everybody to the A4. For you who are looking for A3, it's not existing today. It's A2 on that side and A4 over here. And now we're going into the different sessions instead of keynotes. And I would like to present Grace Jansen. And we're going into this one, and afterwards there will be lunch break. So if you have a lot of questions, please come down and have it. Otherwise, I have a microphone here. Just wave, and I will try to pick you up. Take over.
Thank you so much. Thanks everyone for joining. I know there are lots of great sessions during this this time slot, so I really appreciate you guys coming to this one. I see some familiar faces. Hi, thanks for joining. People from the workshop yesterday, nice to see you again. My name is Grace Jansen. Don't let the name fool you. I am very much English and not Scandinavian or Dutch, so please don't test me on the language because I will utterly miserably fail. But I come from the UK. I'm from IBM. I've been working there for the last 7 years in the Java and cloud native space. Before that, I was studying biology at university. So my knowledge of fish has come in really handy in Java. So today, I'm actually going to be using my biology passion and background to sort of bring an analogy into the world of cloud native applications. So we're going to be taking a look at how we can all become cloud-native doctors by utilizing things like metrics and traces to be able to diagnose our cloud-native applications. And hopefully we're going to sort of learn a bit about medicine, but also about how we can apply those concepts in software engineering, and then look at some tools. And because we're all developers, you'll be pleased to know, hopefully there'll be a live demo, if the demo gods are loving me today. They weren't loving me yesterday during the workshop, but hopefully today is different. So we'll see. So why medicine? What can we actually learn from medicine? Why have I used this analogy when it comes to observing our cloud-native application? And really, when we start looking at medicine and the study of medicine and becoming a doctor, what doctors are all about is diagnosing ailments and diseases and illnesses and conditions in the human body. And it's a really complicated task. It requires years and years of dedication to the science of understanding key body functions and metrics. And those key biometrics are how, a lot of the time, doctors utilize these biometrics to be able to actually figure out what's going on, what's gone wrong, particularly in this specific person. They use things like physical symptoms, written notes it might be, heart monitors, blood oxygen levels. There's a ton of different biometric data that they can sort of feed off to be able to figure out patterns and trends and understand what's going on. And it's really not that different when it comes to software engineering. We also use metrics, they're just a little bit different. So we might use things like app health, we'll look at things like API requests, memory consumption, network traffic error rate, and we also try and figure out trends within those metrics, within that data, to figure out, is my application behaving like I expected it to, or is something going wrong? However, when it comes to diagnosing, there's one key difference in medicine, which is what I'm trying to pick up here in software engineering. And that's that when it comes to diagnosing in medicine, it's very, very, very different diagnosing adults than it is diagnosing babies. And that's not the language barrier in this case. It's just the fact that they simply can't communicate at all. So we lose this all-important context. So, for example, if someone presented with a headache, if they've fallen over the day before or they've not drunk a lot in the last couple of days, it's probably a very simple case of dehydration or you bumped your head, it's nothing serious. But without that context of understanding that they didn't drink, they bumped their head, they might have a preconditioned existing condition in their family, for example, without all of this context, it becomes almost impossible to actually understand how those symptoms might actually be the result of a condition. And it might be, that simple headache might actually be some kind of worst case scenario brain tumor that they were able to pick up. So there's a huge spectrum of different diagnoses we can have just using metrics without that context. And this is where we can really utilize sort of context in our ability as software engineers to diagnose what's going wrong in our applications to become, hopefully, cloud-native doctors. So hopefully I've convinced you that this is going to be a great session and we're going to all become cloud-native doctors at the end of it. So how do we go about doing this? And it's all about observability. So being able to accurately observe our applications and apply that all-important context to the metrics that we're seeing. So when it comes to actually implementing observability, conceptually, in theory, it's actually relatively simple. There are 3 key steps. Step number 1 is instrumentation. So when it comes to instrumenting, what we really mean is making sure that you're able to collect the metrics from your application that we need. So that might be metrics, it might be traces, it might be logs, lots of different data we can collect. But we need to make sure that our applications are actually producing this data and that we're able to instrument our applications to create and produce this data and collect it as well. Once we've got that data, step number 2 is to send that data to an external separate system that can then store and analyze it. And you're probably already making use of this in your own applications already. Things like tools like Zipkin, Jaeger, OTel Collector. There's a lot of tools out there that can allow you to do this successfully. And then step number 3. So once we've got that data stored somewhere, once we're able to analyze it, it's all well and good having a bunch of data, but if we don't understand the trends within it, if we can't visualize and see those trends, we're not going to be getting much information or insights out of it. And that's where visualizations and insights and being able to do things like query analysis can be really important as that 3rd step. So again, you might already be using tools for this, things like Prometheus, Grafana, Kibana. All of these tools provide really powerful graphics and visualization dashboards and query analysis to be able to achieve this 3rd step. Now, you'll be pleased to know, because we've only got 50 minutes, we're not going through all of this in just 50 minutes. That would be a whole day workshop. What we are going to focus on is that 1st stage, that instrumentation. So how can we efficiently and accurately enable our applications to create and collect the data that we need to be able to do steps 2 and 3 and diagnose our applications? So for that, we're going to take a look at these 3 key pillars. So these are the 3 pillars that are identified in many of the open source frameworks that enable observability in your applications. We've got logs, we've got metrics, and we've got distributed traces. Now, this is not to say that this is an exhaustive list. It's not. There's other metrics and types of data that we could collect, other pillars. So for example, things like end user monitoring, profiling, and these are starting to be introduced into things like Open Telemetry, the CNCF Foundation's projects, to be able to add to the existing data that we already collect and use. But in the interest of time, we're just going to stick with the fundamental 3. So metrics, logs, and distributed traces. I'm not going to spend too long on the first 2, because I know a lot of you within here will already be doing this. But just in case there's newbies, or just to get everyone on the same level playing field, I'm going to quickly skim over them. So the first of those is logs. Now, I assume most of us in the room are using logs. If you're not, feel free to come down and we can have a whole chat about it and why they're important. In fact, I'm sure many people will join in with that conversation. But logs are probably the one thing that you are already using here, if any, and they are by far the easiest to generate. They're essentially just very simple time-stamped messages, usually emitted by a service within your application, and it provides that sort of coarser-grained, higher-level information about what's happening at a particular point in time in your application. Logs are fantastic in terms of giving us that really quick information of what's happening whilst our application is going on. They're found almost everywhere in software engineering, and they've been heavily relied upon for many, many years to understand system behavior. The thing with logs is that they're not particularly great at enabling us to track code execution, because they normally lack that contextual information that I was talking about. They're great for sort of time-stamped, this happened at this particular point, but understanding what caused that isn't necessarily what logs are great at. Then we move on to metrics, the second pillar. So when it comes to metrics, this is where we start collecting lots of numerical data that we can then put together and understand trends within them. So metrics are fantastic when it comes to being able to do mathematical, probabilistic, or statistical transformations on them to be able to understand what's happening to our application over a period of time. So where logs were sort of at a point in time, metrics are great for understanding this is how my application is behaving over this period of time. So we can start to spot those trends and understand if our application is perhaps not behaving in the way we expected. However, the biggest drawback of both, I should say actually, if you are not already doing metrics and you are interested in metrics, I'm going to be talking about MicroProfile later, and there is a specification in that called MicroProfile metrics. Now, it depends which version you're using of MicroProfile, because this is currently a changing situation. It's very exciting, cutting edge. However, there is MicroProfile metrics, but we're now introducing some other kinds of metrics in the MicroProfile specification, which I will also go on to. And it relates to what the demo I'm going to show today, but you can use that in your Jakarta EE or Java EE applications if you're not already using metrics of another kind. Now, the biggest drawback of only using logs and metrics is because both of these are system scoped. So what that means is it makes it very hard for us to be able to understand anything else that's going on within a particular system outside of that particular scoping, in terms of applying that all-important context that allows us to be able to understand what led to that particular event or that particular thing happening within our application. And that's where distributed traces comes in. This third pillar allows us to be able to introduce that all-important context into the observability of our application, understanding the steps that came beforehand so that we can understand why that particular sort of resource might have been blocked or memories spiked up or whatever it might be, whatever metric you're looking at, understanding what happened before and why that event occurred. So distributed tracing, sometimes it's just referred to as tracing, but I like to use the whole name because often, this applies to cloud-native applications, which are usually distributed applications, microservices, for example, of some kind. What it does is it's a monitoring technique that links the operations and requests that are occurring between those multiple microservices. It's essentially tracing, hence the name, it's tracing the path that a particular end-to-end request makes as it moves between one microservice and the next, so as it passes through various services within your application. Without tracing, it can be really challenging to exactly pinpoint the cause of performance problems, especially in these distributed systems, which might be all over the cloud. So distributed tracing is really important to help us provide that context and pinpoint down so that we can really debug efficiently anything that might be going wrong in our application. When it comes to tracing, there are some key concepts that it's important you're familiar with as you start to maybe introduce them or learn about them for your own application. The first key word is trace. As I kind of said before, the trace is really the overarching path. So it represents those requests, and it normally consists of multiple spans. That's the second keyword, spans. So a span is a representative of a single operation in a request. Basically, it's just essentially a bunch of information grouped together. So things like metadata, so things like name, time-related data, log messages, any metadata information that can give us additional information on what's going on during that transaction. So you can see in my diagram here on the left-hand side for you guys, that we've got the orange representing the trace and the sort of pinky color representing the single operation, that span that's happening in each of my services. And this diagram sort of illustrates how that trace begins in one service on the left-hand side here and sort of iterates through the multiple spans as it goes from one service to the next within my application. Then we have the all-important context, this third keyword, and really the part that sort of links us into that medicine analogy that I had, understanding the sort of series of events beforehand so we can gain a better idea of what's going on. So context is an immutable object contained in the span data to help us identify the unique request that each span is a part of. Essentially, the trace context is composed of typically two different values. One value is the trace ID, the trace identifier. This is the unique identifier that's normally generated in that very starting request, so right in that sort of root span, and it's intended to identify the entirety of the trace. So what that means is we can understand that even though these are multiple different operations happening, they all belong to that single request as it's moving through our system. Then we have the parent ID, the parent identifier. This is the span ID of the parent that spawned the current operation. I feel like that was just like a tongue twister waiting to happen. Essentially, hopefully what you can see from my diagram here is where we start with the browser application. This span ID has an ID of ABC123, which means the parent ID of that context is the same, ABC123. As we move on to the next point, the parent ID changes and becomes the span ID of that parent microservice. So with these two values, the trace ID and the parent ID, what that allows us to do is understand for any given operation, it's possible for us to determine the root service, the originating service in which that request occurred, and then for us to be able to reconstruct all of the parent or ancestor services in order that then led to that operation. So we can essentially step back bit by bit to understand, right, this came before this, came before this, came before this, and that series of events is what caused this one to happen. So it gives us that all-important context of what's going on within our application, which is why it's such an important third pillar in observability. Okay, so hopefully I've convinced you tracing and distributed tracing is really important, and it's something that you guys should be considering if you're not already using. But how? We're developers, we want to know how we can actually go about doing this. So Open Telemetry, I wanted to introduce this. This is an open source community project in the CNCF. It is actually it's got the second largest number of contributors in the CNCF, just behind Kubernetes. So it's a pretty big project, growing, got a big ecosystem behind it, lots of people contributing to this. And really it was designed to tackle this issue of, in the past, the way in which code was instrumented would really vary because each observability backend would have its own instrumentation libraries and agents for emitting data to the tools. What this meant was there was no standardization. So you had to learn various different libraries or backends or ways in which you were emitting the data in specific formats to be able to actually utilize any of these observability backends. And so what this community aimed to do was to really create that standardization. Now, ironically, it started with 2 standards. And I think that's a little ironic, given that if you've got 2, there's not a single standard. And they kind of quickly realized that. So originally, we had Open Census and Open Tracing. So Open Tracing provided a vendor-neutral API for sending telemetry data to an observability backend. But the issue with that was that it relied on developers essentially implementing their own libraries to be able to meet the specification. So a bit of a faff, really. Then we had Open Census. Open Census was essentially a language-specific library that developers could use to instrument their code and send it to any one of their supported backends. But we basically took the best of both worlds from both of those projects and created this one single standard in Open Telemetry. So if you were using Open Census and Open Tracing, you'll know that they're now deprecated in favor of this new standardization in Open Telemetry. So Open Telemetry is all about being this single standard. It's a high-quality, ubiquitous, and portable telemetry framework to really enable effective observability in your application. It's essentially a collection of tools, APIs, and SDKs. Now, the nice thing with this is that it's multilingual. So I know many of us here will be Java developers. We are at JFocus, after all. But it doesn't mean that you can only use this with Java. You can actually use it with loads of other languages. There are lots of different SDKs depending on which language your microservice is using. So the nice thing is, if you have microservices in different languages, you can actually use this framework across all the microservices within your application, which is pretty useful and handy. Okay, so the one thing I should say, which I haven't said yet, is this last point here about Open Telemetry not being a full observability backend. Now, that is a really important point to consider because what I want to make sure you guys are clear on is if we go back to those 3 steps that I talked about in theory, the instrumentation, the storage and analysis, and the visualization. Now, Open Telemetry is not aiming to solve all 3 of those problems. Open Telemetry is aiming at solving that first issue, that first step, instrumentation. It's actually going to need to be used in conjunction with other tools like Kibana, Grafana, Prometheus, all of these other tools, so that you can do steps 2 and steps 3 as well. So please make sure that that's clear. This is not an end-to-end solution. Instead, it's meant to be used in conjunction for those other 2 and 3 steps. The way it looks in terms of architecture is a little bit like this. So essentially what you have is you have your microservices in that top left-hand corner. and they're feeding in to the Open Telemetry collector in the middle there, as well as observability data that's coming from your infrastructure as well, because obviously we want to know the whole picture here. Now you'll notice I've got this acronym OTLP. We're developers. We love acronyms. I swear it was like Latin when I first joined. I actually had to write a thesaurus to understand everything. Please stop me if I don't go over any acronyms in this. But OTLP is short for the Open Telemetry Protocol. This is essentially the specification that describes the encoding and the transport and the delivery mechanism of that telemetry data between those different telemetry sources, any intermediate nodes, and the telemetry backends as well. This collector in the middle here, this bright yellow box here, that's essentially a vendor-agnostic instrumentation on how to receive, process, and export telemetry data. Normally, it's a single binary, either deployed as an agent or a gateway. You don't have to have it. However, it is really helpful to use, and I'll explain why. If we dive deeper into this OTel collector, this is what you'll see, sort of roughly the processes happening within it. What it allows you to do as developers is by using it, it removes the need for you to have to run, operate, and maintain multiple agents and collectors. And it also helps to improve things like scalability, and it supports loads of different open source data frameworks, things like Jaeger, Prometheus, FluentBit. Again, as I said, you might be wondering, under what circumstances do you actually need to use a collector? Why would you add this into your architecture? What's the need to? So I would say for trying out and just getting started with Open Telemetry, if you just have a demo application, super simple, basic, it's not running in production, you're just testing this out, don't feel like you need to use a collector. You can just send straight from data sources to the data backend. However, in general, we recommend using a collector alongside your service because it allows you to be able to offload that data really quickly, and the collector can then take care of any additional handling. Things like retries, things like batching, encryption, or even things like sensitive data filtering. So all of these things don't have to be a service concern anymore. They can be taken away and just given to essentially the collector as its responsibility to take care of. So we would recommend in production, in enterprise environments, utilizing a collector of some kind. So that's Open Telemetry. But the important thing to note there is Open Telemetry is a specification. You're going to need an implementation to actually make use of it. And that's where MicroProfile telemetry comes in. So has anyone actually, I'll just see if I can see with these bright lights. Has anyone come across MicroProfile before? Please raise your hand. Oh, wow, nice. Lots of hands over there. Cool. OK, it's about half. That's more than I was expecting. That's great. If you've not, don't worry. I'm going to quickly whiz over it. For those who have, bear with me, because I've got some fun breaking news about the newest MicroProfile, so it will be relevant to you. So MicroProfile is a community-driven specification that was created within the community to really drive Java forward into the world of cloud-native applications. So it added on top of sort of enterprise Java these additional capabilities that are really important when building microservice-based applications for the cloud. Things like being able to have reactive in there, being able to use GraphQL, Open API for documentation, open tracing, being able to have health checks, and being able to understand the metrics that are happening within your application. So, and you're actually, for those of you who are keen-eyed, you will notice that a lot of these specifications are actually shared with Jakarta EE. Jakarta EE, for those of you who aren't aware, is essentially the open source sort of downstream version of Java EE. And a lot of these are shared because they're actually created by the same communities. So it's the same individuals and vendors who actually contribute and create these, and they're starting to form a much closer synergy between them for many of these open source APIs and specifications. Now, you might be wondering, why would I even use MicroProfile for my application? What benefits does it give me over something, for example, like a proprietary, for example, like Spring? The nice thing about utilizing something that is a community-driven specification and is open source is that you get all this flexibility. So as you can see, there's loads of different runtimes that support the MicroProfile and Jakarta EE specifications. This I updated this morning, so hopefully this is correct. If it's not, and you're on one of these runtimes, and you know that I haven't got a cross in a box I should, feel free to let me know afterwards, and I'll update the slides. But as you can see, loads of choice. So what that means is that if you want to port your application, say, for example, from Quarkus to Liberty, or Liberty to Payara, or whatever it might be. It's a lot easier because you don't have to re-architecture and rewrite your entire application because the same APIs are supported by each of these different runtimes. So it really gives you the flexibility and portability that we want from cloud-native applications. MicroProfile telemetry. This is where telemetry comes in. This is where it was introduced into the MicroProfile community. So MicroProfile introduced it in MicroProfile 6. This is the second most recent major release of MicroProfile, and it introduced it as Telemetry 1.0. Now, in this, it essentially adopts the Open Telemetry specification from the CNCF and allows us as MicroProfile users, as Java developers, to be able to make use of it in our Java applications. Now, it's important to note here that MicroProfile Telemetry 1.0, the original release in MicroProfile, only adopted the tracing element from the Open Telemetry specification. It did not adopt the metrics or the logging from Open Telemetry. So originally, we were just focused on adding in tracing because we didn't yet in MicroProfile have the ability to be able to sort of store and analyze and collect those distributed traces. However, that has now changed. So for those of you who are familiar with MicroProfile, this might be interesting. So MicroProfile 7, which is the most recent major release of MicroProfile, is where this changed. So now we have Telemetry 2.0, and in this major release, not only do we have tracing, but we now also enable the Open Telemetry metrics and logs. So it's a big step forward. It was actually a big change for MicroProfile because we already had MicroProfile metrics. Now, we haven't completely gotten rid of that. It's been moved to a standalone project. So it's outside of the sort of stack, the stack that you get as standard with MicroProfile as a dependency. And so in favor of putting in Telemetry 2.0 into that stack. Now, the demo I'm going to show today is only focused on the tracing element. It's using the original tracing 1.0 specification from MicroProfile. However, we're going to be coming out with a blog. So who's excited for that? There is going to be a blog really soon. We are currently writing it on these changes and how you can make use of the Open Telemetry metrics and logging as well as tracing in your Java applications. So do look out for that. If you're far too excited and you can't hold yourself from looking, I have put references here if you did want to go and take a look at the original specification for 2.0 to see what changes have been made and how they've adopted those metrics and logging. But essentially, for the tracing part of it, this is how it works in both MicroProfile Telemetry 1.0 and 2.0. So we have 3 different instrumentations. We've got automatic instrumentation, manual instrumentation, and agent instrumentation. So if you are already building Java applications and you are already making use of specifications like Jakarta RESTful Web Services and MicroProfile REST Client, which are 2 of those additional APIs that you might have seen in the stack earlier, you can already automatically enlist your microservices in some distributed tracing. So without making any code changes, you can already make use of distributed tracing. If, however, you are not using those, or let's say you want to add more distributed traces than just the default ones that are enabled, then you can utilize manual instrumentation. So that allows you to be able to add in tracing using annotations. If you're familiar with MicroProfile, you'll be familiar with the fact that most of the APIs and specs within this utilize annotations. So using things like @with_span or using CDI injection with the @inject tracer or @inject span annotations allows you to be able to manually control additional distributed traces within your application. There's also the third option, which is agent instrumentation. So that allows you to be able to utilize the Open Telemetry Java instrumentation project to be able to gather that telemetry data, again, without any code modification. So it's a really handy tool to be able to use to very quickly gain additional benefits when it comes to observing your cloud-native applications. In reality, this is what it looks like. So again, very sort of similarly laid out to what we had before. This is representative of the application we're going to take a look at in my demo. So we've got 2 microservices here. We're collecting data and tracing from both, including that all-important context, collecting those as spans, coming through as traces, and we're sending them to our backend exporter. In this case, we're using the OTLP specification and Zipkin and Jaeger. And then we're just using the UIs to be able to see those. So without further ado, I am going to go on to the demo, because this is the exciting part where everything might go wrong. Hopefully not. We'll have to see. So for this demo, I'm going to be using Open Liberty. Again, has anyone come across Open Liberty? Fewer hands. Thanks for raising. Appreciate. You don't count, Martin. Thank you. Appreciate it. Cool. That's useful. If you've not come across Open Liberty, you might have come across a similar product, which was our legacy product, WebSphere. This is where everyone goes, yeah, get the moans. We very quickly realized that WebSphere, although a great product when it was created, wasn't really designed with cloud native in mind. It's pretty big, it's pretty bulky, it's pretty clunky to use. So what happened was IBM created a project called Liberty, which is a very modular cloud native runtime. So it offers most of the same features that you can get in WebSphere, but this time in a much more cloud native, modular, lightweight fashion. So it's really made with the cloud in mind. We then open sourced that in 2017, and that created the Open Liberty project. So if you're interested, you can check it out on openliberty.io. I'll actually be heading to that website to show you the demo today. Or you can head, I am biased, so this is my own article, so I'm not going to apologize for that. But if you want to go and check it out, I've written some reasons why developers like using Liberty, if you want to check it out as well. But today we're going to be utilizing the Open Liberty interactive guides. So we are really proud of this in IBM. Our team have been working really hard on creating these interactive guides, and they actually utilize or showcase many of the MicroProfile and Jakarta E specifications that I've been talking about today. So if you're interested in learning more about them, we will probably have a guide on them. If we don't, feel free to open an issue or even create the guide. It's open source. So we're always looking for more people and more ideas. But we have over 65 different guides on our website. So there are lots to choose from. They're only about 20 minutes long. And the nice thing is we have a cloud native environment you can use to be able to go through them. So you don't even need to use or download anything to your local machine, which I know is important because many of us nowadays have lockdown machines because of our work. So to be able to utilize an online environment, all you need is a browser, and then you can get started straight away learning about these technologies. So that's what I'm going to be using in today's demo. This is where we figure out if it's going to go right for me. Right. How is the size? Happy? Excellent. I see thumbs. Thank you. Okay, so I'm on the Open Liberty website. The way I got here was openliberty.io. We head to our guide section, and as you can see, 44 in develop, 12 in deploy, build and test, and a few in deploy, although I don't know why my scroller's not working. So loads of different guides for you to choose from. So if any of the others like CDI, health, any of those interest you from MicroProfile, feel free to go and find the corresponding guide and go through it after this session. But what we're going to be doing is we're going to be doing the observability guide today. So we're going to be doing this guide, enabling distributed tracing in microservices with Open Telemetry and Jaeger. Now, if you see this running cloud option, that shows you that you can utilize our cloud native environment. Again, all free. It's based loosely on the open source IDE Thea, and it gives you everything you need in that online environment. If you see this, new, it's exciting and new, so that's exciting. When you click on, in fact, I will show you it because it will make more sense. When you click on the guide, it will appear with a page like this, and this is the running cloud option. Now, if you don't want to use our cloud native environment, that's totally fine. You can also do it locally, but you will need to make sure you have the prerequisites listed in the top right of each guide. And you can just go through the instructions here, and it will pop up with the code that you need on the right-hand side as and when you need it. But in this case, we're just going to use the running cloud option. And when you do click that, it will appear with a page that asks you to log in. We didn't ask for a login originally, and then Bitcoin miners found us. So we now have to ask for a login, unfortunately. Yeah, ruined it for everyone there. Oh well. But the login you can use is loads of different social logins, including things like GitHub, or you can just register with an email. So lots of ways that you can log into our system. Hopefully one of them works for you. So I've logged in with my GitHub for just now. And I've actually already opened this up, and hopefully, yeah, it's still running. Excellent. I did have to ask them to increase the time allowance because I speak for far too long. So we've now been able to increase this for these guides. Okay, so when you come into this online environment, you'll find that the instructions are on the left-hand side. It gives you a bit of information about what you're going to be doing in this guide, what you should hopefully learn by the end of it. On the right-hand side, you'll find your IDE, and normally in the bottom right, you'll find your terminal. If you don't find a terminal there, don't panic. You can just see terminal, new terminal, and one will appear. You can use the Explorer to be able to explore our sort of directory structure if you want to. Right now, I've already gone through some of the instructions just so that we could save some time for this demo. So in this, like I mentioned, this is loosely the architecture I showed you before. We have 2 microservices. This is the same application we use for most of our guides. It's a very simple application because we're trying to make sure that you just have to focus on learning the new technology and don't have to worry about understanding what's going on in the app itself. It's just 2 microservices, system and inventory. The inventory microservice essentially, the system microservice scrapes, I'm getting confused. The inventory microservice scrapes your system data every 15 seconds, and then the system microservice stores essentially the other way around. The inventory microservice stores a store of all of that data from the system microservice. So it's very simple. There's not that much data in there. It's very simple back and forth calls, but it's just so you can understand the new technology. So in this case, I've already done these instructions to clone the repo, and we've CD'd into this directory structure. As you'll see, we've got a finish directory and a start directory. This is the same directory structure we use for all of our guides. If you don't want to go through the instructions and you just want to see what it looks like, you can just go to the finish directory, and that shows you what you should get to at the end of all the instructions. So it's a completed app with all of the stuff that you should be learning about for this particular lab or class or guide. So in this case, MicroProfile telemetry. It gives you an example at the start here where you can actually go into the finish directory and see what it should look like before you go through the lab. In the interest of time, I'm going to skip that step and just go through the instructions to show you. So the first step I'm going to need to do, I'm going to close this just so you can see. There we go. So the first step is I'm going to CD into one of those microservices, in this case, system, and I'm going to get it started with Maven. So in all of our guides, we utilize Maven just to make sure it's consistent and easy for you to use. You can use Gradle with OpenLiberty or Ant. I'm not going to judge. But we just use Maven for ours because it makes it much easier and much more straightforward because we just use the same one and it's consistent. In this case, I'm using the command maven liberty dev. So this is running Liberty in dev mode. Now, what that means is that essentially the OpenLiberty server is running in the background, listening for configuration and file changes and code changes to your application in real time. So it will make those changes, it will update your application in real time by updating any classes or configuration that you've changed without having to tear down your whole application and restart it back up again. So it makes life a lot easier when you're doing agile development and you want to see those changes happening in real time. So you should know that it's up and running when we get the message. Yep, here it is. It's a bunch of stars. Liberty is running in dev mode. So what I need to do now is I need to open a new terminal because that terminal is currently taken up by that Liberty server listening for changes. And now I'm going to do exactly the same, but this time for the inventory microservice. So I can get both of them up and running with Liberty in dev mode, listening for any changes that I'm making to my application. In the meantime, what I did before this session started was I had a Docker command that I used here to be able to run Jaeger in the background, so it was listening for any tracing data that I was going to start producing from my applications. So I've already got that Jaeger UI up and running here. If I refresh, thank God the Wi-Fi is working. So as you can see right here, we don't have any services yet because I've not set up any distributed tracing to them just yet. All right. Hopefully this is working. Perfect. Yep. So we can see in the second one, we now have another microservice up and running using dev mode. So now what I'm going to do is run this curl command again in another terminal because that other terminal is taken up by that OpenLiberty server. So I'm going to run this curl command, and this is really essentially finding the system service. And then we're going to do the same for the inventory microservice. It's not got any systems yet because it only scrapes every 15 seconds, and I've done it a bit quickly here. But as you can see, I've got a bunch of information from my system that I'm scraping every 15 seconds. So now, if I continue, so now we're going to enable the MicroProfile telemetry API, and this time we're going to do it, the first one, through the automatic implementation option. So the first thing I need to do is replace the server.xml. We've tried to make this really easy in this environment for you by adding in all of these buttons in the instructions that allow you just to be able to very quickly execute commands, copy and paste code. So we've actually given you the whole class here that you'll need to copy and paste over. So I've just deleted that server.xml from before and replaced it with the new one. In this case, you can start to see, so for example, here's a feature that I've added. As you can see, we're using 1.1. There is 2.0 out, and we are looking at updating this guide. We've just not done it yet. So we're just focusing on the tracing element in this one. So I've added in that MicroProfile telemetry feature and enabled it in the system service. Now, this IDE does not automatically save, so do make sure if you do have a go with any of these guides that you are saving as you go along. You'll know if it's not saved because there's a little white dot in the top corner of the tab. Now, I'll need to do the same for the inventory microservice. So again, I'm going to open up that server.xml, copy and paste in the code that I have here, and make sure that I save. You can see that dot, oh, where's it gone? The dot in the top right shows that I've not saved it. And as you can see, I've added in, again, that feature as well, MicroProfile telemetry. You can also see I'm utilizing some of the other sort of APIs from MicroProfile here, like CDI, JSONB, RESTful, config, that kind of thing. So now that it's enabled in our server.xml, it's kind of weird. I don't really understand why they did this, but MicroProfile tracing is by default off, which I didn't really ever understand. So we need to turn it on. So to do that, we're going to utilize MicroProfile config. So what we're going to do is make a MicroProfile conf. Oh, have I gone in the right one? Yeah, there we go. Is make a MicroProfile configuration file. This one's for the system service. So then if I open that up, it should be empty because I've only just created it. And I'm going to add in these configuration values here. So we've got the system name, which in this case it's system. And then we've got the fact that we're turning disabled to false. It's kind of a weird like double negative going on here. But essentially what we're doing is turning tracing on. Now, if we go to the same file, so MicroProfile config properties for the inventory, we have already got a value in here. But essentially all we're doing is adding to this class with those additional configuration values. In this case, the name is inventory because we're in the inventory microservice. And again, we're turning it to false. So now what we're going to do is, again, run the system and inventory services using this curl command. Now, when I visit Jaeger and refresh, hopefully, fingers crossed, there we go. Yep, so you can see system and inventory are now showing up in Jaeger for my microservices. If I click find traces, I can already see I've got some tracing and some spans within my application. Because I'm using Jakarta RESTful Web Services and MicroProfile REST client, I was able to automatically enlist those already in distributed tracing without making any code changes. So you can see in just a few, like that was literally a couple of minutes, I've already been able to introduce distributed tracing into my application without making any code changes. Now, the next steps of this guide are to take you through the manual and the agent instrumentation, utilizing things like the @inject annotation, for example. If I just scroll down and show you some of these, because I'm not going to have time to go through this whole guide today. Here we go. So this is utilizing Jakarta CDI beans, so another API that you can utilize. And this one's using the @with_span annotation. So essentially, it's going into this inventory manager.java class, and in here, we're introducing the @inject, and we're also introducing the @with_span annotation to be able to manually add in some of those distributed tracing to areas that weren't already automatically enlisted when I did the automatic implementation. If you want to continue with this guide, it, as I said, goes through manual and then at the very end, agent. Do bear in mind that at the end of all of our guides, it's really important that you stop any Docker that's running and you also clean up your environment because it will remember your environment if you go and start a new guide. So if you've already got a repository from another guide, it might muck things up. So just remember to follow the scripts that we've got to make sure you go to that last page and clean up anything if you are doing this in your own time. Okay, in the interest of time, I'm going to go back to this. Perfect. Hopefully this will work. Excellent. So, hopefully, in summary, what I've shown you today is that we are entering a world of increasing complexity, but we can learn from other areas in our lives, like medicine, like doctors, to be able to add in that all-important context when it comes to observing our applications. And that effective observability is really critical to monitor and understand how our applications are behaving. And to be able to do that, context is key. So making sure we have all three pillars when we're instrumenting our applications: logs, metrics, and those all-important distributed traces. But the nice thing is, I'm not just sending you out to do this all on your own. There's loads of different open source tools and technologies and communities out there that can help you with this, like Open Telemetry, the CNCF, MicroProfile, all of these communities and tools that you can make use of. If you are interested in finding out more, you can check out some of these blogs that sort of highlight some of the theory I've gone through today, and also have some of the demos and sort of like labs that we've gone through. They're all available on GitHub, all open source, so feel free to check them out if you're interested. If you did want the presentation slides, I have already uploaded them to SpeakerDeck, but they are also now on the JFocus website as well. So if you don't manage to grab this or don't want to go to SpeakerDeck, you'll be able to find them on JFocus too. I was prepared this time and uploaded them beforehand, which is great. If you're interested in learning more about Open Liberty, from what I've shown you today, feel free to reach out to us. We're on Twitter and LinkedIn. I run the social accounts, so I'll say hi if you follow us. If you find a bug or anything, or have an idea for a new guide, we'd also love to hear about it. So do get in touch if you have any ideas. With that, I'm going to say thank you so much for listening to my session today, joining me, especially when there were so many other great sessions on. And please do remember to vote for the sessions today and tomorrow. I think I have the right QR code. Hopefully, we've set it up correctly. Oh, have you got your mic on?
/rate.
Yeah, so it's jfocus.se/rate.
Yeah, and then you look for this session, and then you vote for this one.
Yes. So make sure you're voting for the right session. But if you didn't enjoy today, my name is Brian Vermeer, and you can vote for his. But I really appreciate you coming today. If you want to reach out to me on Twitter or LinkedIn, then feel free to contact me with the links above. Thank you so much, guys. Feel free to come down to the front and speak to me. We've got lunch now, so we've got some time.